Okay, so this is attached to Thursday's Google Classroom assignment, so pull it up, okay? As a refresher, the class already went over this, but what you're gonna do is you're gonna have a molecule here, and then I'm gonna put it here, okay? Despite what's up in this molecule, whether it has 1s or 2s or 4s behind it, you just draw those Lewis dot structures out. Some of y'all can put them together and how they actually align in the molecule, but as long as you do that number and what they are, you're good. Then here, just use what I have. Don't modify it, don't add any numbers, okay? So, Lewis dot structure, okay. Hydrogen. We have hydrogen with 1 valence electron. We have fluorine with 7. 1, 2, 3, 4, 5, 6, 7. So this is actually how they go together, okay. Metals or non-metal. We have non-metal and to non-metal, okay. At first sight, based on our electronegativity pairings, non-metal and non-metal should be covalent. But what I tell you down here is, note, we can tell if most molecules are ionic or covalent by this general rule. Metal, metal, same, not too much different, covalent, they share. Non-metal, non-metal, similar, share. Metal, non-metal, very different, steel, ionic. But you still need to check the electronegativity. So remember, when it's lower than 0.5, it's covalent. There's not really a polar difference. If it's higher than 0.5, then there is polarity. And even if it is a metal-metal covalent or non-metal covalent, if that is greater than 0.5, change it to ionic. Okay, so ready? Right now, it looks non-metal, same, covalent, but let's check the electronegativities. Electronegativity of hydrogen is what, 2.1? What is fluorine again?
4.
4. So the absolute value of that is 1.9, sorry, 1.9. Wow, that is way greater than 0.5. So it is polar. And now, instead of me thinking it was going to be covalent, because it's polar, it is going to be ionic. Okay? Let's do O2. Now, anything that's diatomic, which means it's the same thing, it's going to have an electronegativity of 0 because it's the same thing. So, O2. Look on our table, 6 valence electrons. We got O, 1, 2, 3, 4, 5, 6, O, 1, 2, 3, 4, 5, 6. It really doesn't matter what side. O's will double bond to each other. So this one will bond here, this one will bond here. But right now, I'm just asking for the Lewis dot structure, okay? Okay, metals or non-metals? Well, based on the periodic table, they're looking like non-metals. Okay. Electronegativity, it really doesn't matter what it is, but what is oxygen again, 3.5?
Yes.
3.5 minus 3.5 equals 0. Okay, when it's the same thing, the difference is just 0. So 0 is less than 0.5, so it is going to be nonpolar. And it is non-metal, covalent, and its electronegativity is nonpolar, so it definitely is covalent. Okay, let's move to the next 4. Okay, CH4, okay, so our carbon has how many valence electrons?
4.
Good. We spread them out north, south, east, west. Now, you might have drawn 4 individual hydrogens, but this is how they actually line up. We got a hydrogen up here sharing that spot. We have a hydrogen here sharing that spot. We have a hydrogen here sharing that spot. And we have a hydrogen here sharing that spot. If you just took 4 of them and lined them up, that's fine too. But in real life, that's actually how it lines up. That's how the 4 actually attach, okay? If you didn't do that, y'all probably didn't do it, it's still right. As long as you did draw 4 hydrogens with their 1 valence electron. Okay, off the top of my head, carbon, what is that?
Non-metal.
It looks like a non-metal. Hydrogen?
A non-metal.
Non-metal. Okay, it's looking like it's gonna be covalent, but we gotta still go through. Electronegativity difference, what's carbon?
2.5.
2.5. Hydrogen is 2.1. The absolute value of that is what?
0.4.
0.4. 0.4 is less than 0.5, so it is nonpolar. And we were right to assume non-metal, covalent. Okay. Let's move over to KCl, okay? K,
Only has one.
yeah, it's in group 1, so it's just one valence electron. Cl, 7. Cl, 1, 2, 3, 4, 5, 6, 7. Yep, kind of pairs up like HCl2. Okay, so now metal or non-metal?
K is a metal.
K is definitely a metal. Cl
Is a non-metal.
looks like a non-metal. And remember, some of these that are like by the the metalloids, they still can act wacky. That's why we always have to do the electronegativity. K, what is K's electronegativity?
2.1.
2.1, y'all agree?
No.
0.8. Wait. I did something wrong then.
You might be on that first one. 0.8 minus what is electronegativity of chlorine? 3.0. Okay. What is the absolute value of that? 2.2. That is way greater than 0.5, so it's polar. And the metal plus the non-metal, which is usually ionic, was verified because it is polar here too, so it really is ionic. Good. We thought it was going to be ionic, but now we verified it's definitely going to be ionic.
So anything greater than 0.5 is going to be
Yes, so even if we, based on our rules up here, thought it was going to be covalent, we'll switch it based on the real numbers, yeah.
But when it's 0.5, we just go off of the rule.
Yeah. Okay. Let's go to this next one. Okay. This one may or may not actually exist, but I want you to try to do them with a lot of metals, metal, non-metal combinations. So we have oxygen, valence electrons, 6. 1, 2, 3, 4, 5, 6. F, fluorine, 7. 1, 2, 3, 4, 5, 6, 7. Okay. Now, metal or non-metal? What do y'all say oxygen is?
A non-metal.
Non-metal, I agree. Fluorine?
Non-metal.
Non-metal. Okay. Electronegativity difference. So what is the electronegativity of oxygen?
3.5.
3.5 minus
4.
4.0. Wow, so that gives us a 0.5. Okay, so then what I would do, because I wanted you to think like, what would I do? It's exactly 0.5. Go back up to what our normal rule is, and non-metal plus a non-metal, our normal rule with it would be
A non-polar.
non-polar and covalent. Good, so we normally thought it was a covalent bond, and then it's non-polar. Okay, Cl2, yes, I meant little l, okay? So Cl2, Cl valence electron 7. So we have Cl 1, 2, 3, 4, 5, 6, 7. Then we got another Cl 1, 2, 3, 4, 5, 6, 7. Okay, happily bonded to itself. Okay, what is chlorine?
Non-metal.
Yep. Non-metal plus a non-metal. Based on our rules, we think it's going to be covalent, okay? Electronegativity difference, if it's the same thing, it's going to be 0, but what is the electronegativity of chlorine?
3.
So 3.0 minus 3.0, absolute, equals 0. That is less than 0.5 non-polar and non-metal, covalent. Okay. Let's do our last set of 2. Okay, CaCl2. Calcium, how many valence electrons for calcium?
Calcium is
Or
2.
2 under it.
Perfect. So it's Ca, 2 valence electrons. Okay, Cl's have 1. So if I do a Cl on this side, oh, I'm sorry, so 1 opening, 7.
Yeah,
1, 2, 3, 4, 5, 6, 7. Cl. 1, 2, 3, 4, 5, 6, 7. You see how the Cl's fit perfectly with the calcium? Okay. Now we need to find out if they're actually stealing those calcium electrons. Okay. So metals or nonmetals? Calcium is
A metal.
metal. Chlorine is a
Non-metal.
non-metal. So we're hypothesizing it is going to be ionic, but first let's do electronegativity to double check it. What's calcium's?
1.
1.0, okay. Minus chlorine's?
3.0.
Wow, so that gives us electronegativity of 2.0, which is huge, so it is polar. And based on that, plus the rule up here, it definitely is ionic. Perfect. And then NaCl, we have sodium and A valence electron 1, perfect. Cl, man, we like Cl, 7. Cl, 1, 2, 3, 4, 5, 6, 7. So they pair up really nice. We got sodium metal, chlorine non-metal. We're hypothesizing it's going to be ionic, but let's do electronegativity. What is sodium's?
0.9.
0.9 minus chlorine 3 gives us a
2.1.
2.1, very polar. It's above 0.5. So what we suspected about it being ionic is true. Your quiz tomorrow is going to be exactly this. I will even give you the hints here. So you could even have this right here, which is exactly what's on the board. I'm just going to give you different molecules. Okay?
Can we use this one?
And you'll have an electronegativity chart. Yep.